Good morning. Today we're going to be working on multiple transformations, so I can't be with you today. Well, first let's start with just going over x-axis reflections and y-axis reflections because we never went over those. This was left out of your notes by mistake. So with x-axis reflections, we have that in our notes, negative f of x, meaning you make the whole equation opposite sign. So convert whole equation. I'm going to put negative, but if it's already negative, then it would turn into a positive. So multiply everything by -1, basically. So here, given the graph y equals x plus 4, do a reflection of the x-axis. So I'm making this whole equation negative. So f of x equals negative x plus 4. And then you can distribute it just to see how it graphs. Negative x minus 4, right? So negative x minus 4, that is a linear equation. I want you guys to remember, you start at your y-intercept, and then you have a -1 slope. So my y-intercept's -4. 1, 2, 3, 4. And you can tell that's right because I was at +4, reflect it over my x-axis, which is 4 to get to my line of reflection, 4 spaces to get to my other side. And then I have a slope of -1, down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. You want lemonade, little girl? Okay, I'll go get you some lemonade. Oops, and then try to make that line. I'm home because my daughter is sick, just so you know. And now she's requesting lemonade, so. Okay, so for my table students, I know some of you just like the table better than just graphing it. The original is your linear, so -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. And then this original graph is up 4, so I added 4 to the original linear graph. So that's how I got 2, 3, 4, 5, 6. Now, if I'm reflecting it over the x-axis, I am changing the signs of my y values. So if I was at 0, 4, now I'm at 0, -4. So all the y values are changing signs. So if it was positive, it would become negative, but all of ours were positive, so they're all going to become negative. So there's your answer. Okay. All right. If you're reflecting over the y-axis, this is the new part. You're going to plug in -x because you changed the sign of the x-axis, x values. So again, the y values, when you reflect over the y values, the x values change. So when I'm plugging in -x to reflect it over the y-axis, only the sign with the x is going to change. And if this was like a quadratic or something, you would want to put it in parentheses. Since it's linear, those parentheses aren't going to do anything, but it's not going to hurt it to leave them there. So my original points, again, are the same as over here. So then my new points, I'm changing the y value. I keep saying the wrong thing. I'm changing the signs of the x values. So it was -2. Now it's +2. So this point, -2. I wrote those wrong, didn't I? Because look, -2, 1, 2. -2, 2. Okay, no, hold on, that's right. So -2, 2, reflected over the y-axis. It's 2 to your line of reflection, so 2 to the other side. So it'd be over here. And you can do that to every single point. 1 to your line of reflection, 1 to the other side. 2 to your line of reflection, 2 to the other side. But, so now it's reflected over, try to hit your points. There you go. Now it's reflected over the y-axis. So it's 2, 1, 0. Now from 1, it becomes -1 and -2. And I graphed those at -1, 5, 1, 1, 2, 3. 2, 1, 2. See? Okay, so that's reflecting over the x-axis and y-axis. Go ahead with drawing transformations, multiple transformations on one graph is a little more complicated. I went ahead and drew the parent functions, but with multiple transformations, you have to go in order. Just take a note here. These are basically just following the order of operations. You start inside your parentheses, which is left and right, your horizontal shifts. Horizontal shifts left and right start in the parentheses, and then you do your multiplying and dividing. So multiplying by a number bigger than 1 or less than 1. And I go ahead and do negation here too, because instead of multiplying by a positive number, you multiply by a negative number. Not a big deal. And then add and subtract your vertical shift. But so to simplify this a little bit, 1 is first thing you want to do is look at left and right. And that's the only one that's going to change the x value. Then you look at your multiplication, vertical stretches, your vertical compressions, and I go ahead and throw in negation in this one step, like reflections, I guess is how I should put it. I'll change that to reflections. All right, and then lastly, you want to do your vertical shifts up and down. Okay? All right, so pause it if you want to copy all the words down. If you just want to copy, first do left, right. Second, do vertical stretch, vertical compression, reflection. And third, do up and down. Your choice, your notes. I'm not ever taking them up. But let's do an example. So here it says, do not rearrange or simplify, just so you get the hang of the patterns that you're going to be using. So we have our linear functions. We're going to start in our parentheses. Remember, plus is actually left 2. We're going to go left 2. And then what's going to happen is you're going to multiply it by -1. So that's a reflect over the y-axis. I apologize, over the x-axis, because it's just it didn't change the sign of the 3. Reflect over the x-axis. And then down 3. Okay, you can do this to every single point. So I'm going to start with 0, 0. I'm going to go left 2, 1, 2. I'm going to reflect that over the x-axis. Well, it's already on the x-axis, so it just stays right there. And then I'm going to go down 3. 1, 2, 3. Here's that point. And I can keep going. So 1, 1. Left 2, 1, 2. Reflect over the x-axis. So I'm up top, 1 to my line of x-axis, my line of reflection, 1 to the other side, and then down 3. 1, 2, 3. Okay, let's do it again. 2, 2. Left 2, 1, 2. Reflect over my x-axis, 1, 2 to my line of reflection, 2 to the other side, and then down 3. 1, 1, 2, 3. So here is my line. You can already see it. So you know the pattern. Da, 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 da. Since this is linear, it's not a hard one to check. You can just distribute, right? Distribute negative. So that's negative x minus 2 minus 3. So negative x minus 5. So starting at -5, 1, 2, 3, 4, 5. I have a slope of -1, down 1, right 1, down 1, right 1, down 1, right 1. For my table people, I know I got table people. I suggest taking your original points, that's your parent function, changing your vertical, I'm sorry, oh my goodness, can't speak this morning. That's probably because it's 8:38 and you're all getting in my classroom right now. I change your values for your x. So the only x that's going to change is a left 2. So I'm going to move all these points left 2. Well, left 2 is minusing 2 from my points, even though the equation looks like +2. I'm minusing 2 to all my points. So -4, -3, -2, -1, and 0. And then plug these values into your equation. Okay? Okay, so I went ahead into the calculator. I plugged -4 into this equation, -3 into that equation, and get my points with -4, -1, -2, -3, -4, -5. So with -4, so I said -1, -2, -3, -4, -5. So once you know what the x does, like how the x shifts, you can just shift all of your points. I hope that makes sense. All right, let's do the last two, and then I will post this video probably at 8:45. So I'll probably get emails like, hey, it's not posted. That's cool. I'll figure it out. So we're going to go inside first, left and right first. -1 is right 1. That's the only thing that's going to affect your x values. The next one, in order, it'd be 0.5 since it's less than 1. That's a vertical compression by 0.5. And then reflect over the x-axis. Puka, no kisses. Sorry, my dog's looking at my little girl.
Mama.
And then up 3. Yes, baby girl.
Yeah.
All right, if you're looking at right 1, we're just adding 1 to all of my x values. So +1. So I'm adding 1 to my x values. So now it's -1. Now it's 0. Now it's 1. Now it's 2 and 3. So that's my right 1. And then you can plug it into your new equation with all the transformations and just get points to graph. I'm not going to take your scientific calculator away from you on the test day. I'm taking your graphing calculator. So I can just plug those points into this equation and get my new points. If you want to be complicated, you can use your table to do all the transformations at once. So this is right 1. And then remember, I combine vertical compressions and reflections at once because that's all to the y values. So -1, 0, 1, 2, 3. And I'm multiplying by -0.5. So -0.5 to 4 is times. I don't like using the x, like it looks like a variable. So that'd be -2, -0.5. 1 to 0 would still be 0. To 1, again, -0.5. To 4, -2. And then the last transformation would be up 3. Well, that's going to add 3 to all my y values. -1, 0, 1, 2, 3. See, my x values haven't changed since I moved them right 1. But now up 3, I'm adding 3 to all my y values. So 1, 2.5, 3, that goes with the 1, 2.5, 1. So those are my final answers for this graph. This is way harder than it needs to be. So at 1, I'm at 1, 2, 3. At 0, I'm at 2.5. At -1, I'm at 1. I started at my vertex and went out so I can reflect it. So there's my graph. But once you get your x values, put it in your calculator. So let me throw them in the calculator real quick. Okay, so after I do move right 1, -1, 0, 1, 2, 3 are my new x values. -1, I get 1. 0, I get 2.5. 1, I get 3. 2, I get 2.5. 3, I get 1. These tables are how the calculator is doing it, but as long as you can translate your x and then plug them into your equation, you don't have to show me all of these 4 tables. I hope that makes sense. All right, class has started. I'm going to speed this one up a little bit. So I'm going left 1, up 4. I'm going to go ahead and move my asymptote up 4. 1, 2, 3, 4. Because it's not reflecting or doing anything crazy. It's just moving up 4. I'm going to move all my points up 4. 1, 2, 3, 4. Left 1. I should technically move left 1 first. Left 1. 1, 2. Whoop. 1, 2, 3, 4. There we go. There we go. There we go. Here it is. And then this one, left 1, up 4. All right. And there's your graph. Easy peasy. It's a vertical stretch, vertical compression that gets harder. All right. Take these notes. I'm going to post what I want you to do on your project video in a second, but I want to get you started on this. So